Good afternoon, one and all. Myself, I am Professor M.H. Manu. Today we will going to discuss about the small dipole antenna. In my previous video, we understand and to learn about the infinitesimal type of the antenna. So now today we will discuss about the small dipole antenna. First we see which antenna is called as the small dipole antenna. A current element whose has a length is lambda by whose length L is greater than lambda by 15 but less than lambda by 10 is called as the small dipole antenna. In the schematic presentation shows that the current distribution and construction of the small dipole antenna. In the small dipole antenna is generally there are the two poles and which is to be implemented on the x, y and z plane. On theoretically it will be implemented on the x, y and z plane, but on practically it will be implemented perpendicular to the ground plane with reference to the base of an antenna. Then antenna is placed in such a way that its half part will be along towards the positive z axis and remaining half part moving towards the negative z axis. Then we have to be able to find out the electric field at a distance point P where r, theta and phi, because each antenna is able to place it in the spherical coordinate system, and in the spherical coordinate system we have to be able to measure the parameters in the form of the r, theta and phi. R is the radius of the sphere which is constant throughout the sphere, where the maximum radiation should be occurred. Apart from that, the strength of the radiation is going to be decreases. Then the range of the theta is 0 to 180 degree, means we have moved to look the radiation pattern in the vertical motion, and phi is 0 to 360 degree, means we have able to see the radiation throughout the sphere, means around towards the antenna. Then on right hand side the figure is shows that the approximate the triangular current distribution of an antenna. Then we move towards the next point, which is called as the small dipole antenna radiation resistance. Basically the radiation resistance should be calculated twice to that of the radiated power upon the square of the total current is able to flow through the antenna, which is equal to 20 pi square L upon lambda bracket raised to square. Then for length L which is equal to lambda by 10, then its radiation resistance is the 2 ohm. If the length of an antenna is lambda by 4, then radiation resistance is the 12.3. and in left hand side there are the two derivations should be given, means one derivation is the small dipole current distribution and next is the small dipole vector potential. Basically these two derivation is found according to the Maxwell equation, as well as it will be able to find out the basics electromagnetic theory, and dipole have the reactive impedance. After that we have find out next is the input impedance of the transmission line. The transmission line is the very important parameter, because the antenna in itself it will be acting as the transmission line, and transmission line is calculated with the help of the equation Zn, which is equal to Z0 ZL plus ZZ0 plus ZZ0 tan beta L upon Z0 plus Z ZL tan beta L. Again, with reference to this equation, we move to look the schematic representation of the transmission line. The schematic representation of the transmission line having the length L and having the load impedance. That load impedance is connected at the output of the transmission line where input impedance, and at output impedance the Z0 it will be represented. Again, there are the three cases: when your load impedance which is equal to 0, when your load impedance which is equal to infinity, and your load impedance which is exactly equal to that of the source impedances. Then how we have to find out the input impedance? One by one we have seen. In a case first, where ZL which is equal to 0, in case of the ZL which is equal to 0, Then in the above equation we have seen that where ZL which is equal to 0 in the numerator, that's why in the numerator Z0 inside the bracket ZZ0 tan beta L upon where ZL which is equal to 0 means again there Z0 will become in the numerator. In the denominator and numerator, the both having Z0 gets cancelled, and the equation for the input impedance is becoming input impedance is the Z0 tan beta L. In the case second, there is a ZL which is equal to infinity, where Zin which is equal to Z0 upon Z tan beta L. And when your load impedance which is equal to source impedance, then your input impedance which is equal to the output impedance and the source impedances. Then we have seen the beta. What is the beta? Is the phase constant which is equal to 2 pi upon lambda. And again there are the two cases is arises for the transmission line, that is for short circuit transmission line and the open circuited transmission line. If the length L should be less than lambda by 4, then your tan beta L is the positive, and if it is the positive, it will be acting as the for short circuit, whereas ZL which is equal to 0, Zin is the inductive. For that case, when your load impedance which is equal to 0, then your Zin is the inductive, so the transmission line represents the inductance. When your ZL is the infinity, then your Zin is the capacitive, so that your transmission line represents the capacitive. Then there are the next cases is where your length L is greater than lambda by 4, but it is less than the lambda by 2. Then your tan beta L, this parameter is moving towards the negative side. Then we see in the half wavelength dipole, small dipole antenna. Then what is the half wavelength dipole? Basically what happens in the half wavelength dipole means your total wavelength, and for these cases we have to be arranging your wavelength parameters such a way that which is equal to lambda by 2, and this lambda is generally depends upon the operating frequency f, because the speed of the light c which is equal to f lambda, and lambda is a calculated c by f. C is the constant or universal in all over the world. It is the 3 into 10 raised to 8 meter per second. But the operating frequency should be different, because the operating frequency is totally depends upon which type of the antenna or what are the different applications of the antenna, where to be used the antenna. Based upon that you have to be decided the operating frequency. In the half wave dipole antenna, where length L which is equal to lambda by 2, and the electric and magnetic field of the half wavelength dipole is given as E of theta which is equal to j in I0 e raised to minus j kr upon 2 pi r inside the bracket cos pi by 2 cos theta upon sin theta, and h of phi is approximately equal to j I0 e raised to minus j kr upon 2 pi r cos pi by 2 cos theta upon sin theta. Whatever this equation is represented, that the electric field is in the form of the theta component and magnetic field is in the form of the phi component. Based upon that, we have calculated for half wave dipole antenna the directivity of the half wave dipole antenna, which is to be calculated by using the formula 4 pi upon u max upon p radiation, and which is approximately equal to 1.643. Because of that, for in case of the half wave dipole antenna, the radiation resistance is calculated, which is equal to twice that of the radiated power to the square of the total current is able to flow through the antenna, and its value is approximately equal to 73. So that the input impedance of the lambda by 2 dipole is the basically 73 plus 42.5 ohm, and to make it is the imaginary part or equal to 0, and the antenna length is reduced until the input impedance become the real. Then design of the dipole antenna, we design the dipole antenna that is L plus D which is equal to 0.48 lambda, where D is the diameter of the wire, where D is less than lambda by 10, then real input impedance should be equal to 68 ohm. Then after that we have seen the whatever the different cases, how much the current is able to flow through the antenna, the different current distribution of the dipole antenna for the different lengths it will be given, and it will be totally depends upon the length of an antenna. The length of the antenna is depends upon that, when the length of the antenna should be varying from lambda by 4 towards the 2 lambda, means lambda by 4 lambda by 4 plus lambda by 4 means 2 lambda by 4 means it is lambda by 2. Lambda by 2 plus lambda by 2 then which is equal to lambda. Then lambda plus lambda by 2 is the 3 lambda by 2. In this way 4 lambda by 2 means it is the 2 lambda. Means once we have able to decreases the wavelength of an antenna in this way, the current distribution is also varying with respect to the length of the antenna. Then this is the dipole antenna radiation pattern having the length L which is equal to 1.25 lambda. In the left hand side and right hand side the same radiation pattern, but it's how to represent it. First is the two-dimensional radiation pattern and the next is the three-dimensional radiation pattern. Having the directivity is the maximum for thin dipole having the length L which is equal to 1.25 lambda. Then for this case the two-dimensional, the figure of eight radiation pattern is obtained. At 90 degree and 270 degree, because in the z axis we consider it is the theta which is equal to 0 and theta which is equal to 0 to 180 degree. That's why we consider for the z axis theta which is equal to 0 relative power dB in downward direction, means 10, 20, 30, 40 in this way. The first circle it will be represented by minimum to maximum site. Then in the three-dimensional it will be three-dimensional radiation pattern. Whatever the positive signs it will be given, the positive signs it will be indicated by the maximum radiated the power or radiated the signal from an antenna. Remaining all are the side lobe having the negative